Hi all, in this video we're going to try and look at the graphs of sine and cosine separately. So we do know that sine and cosine are related to the unit circle and that's how we get their values, but we want to get a little bit of tunnel vision here and say, okay, well the sine function inputs t's and outputs y's, and can we look at that relationship, sort of step back from the circle and just look at what happens to y as t increases or decreases, and then for cosine as what happens to x as t increases or decreases. Okay, so we have this y value right here that we're following, and it's associated with this t value right here. So we can walk our way really carefully through quadrant 1, and then I'll start skipping some of the special values. So for starters, I know if t equals 0, that I'm sitting right here at this point, and my y is also 0. So t equals 0 gets paired with y equals 0. If I let t go up to pi over 6, my y value should be 1/2. So let's see, let's make this a pi over 2 and a pi and a 3 pi over 2 and a 2 pi. Okay, so a pi over 6 is going to be a little less than a pi over 4. So right around here we have a point. If t is pi over 4, we know, I have them in here from playing around earlier, that y should be 1 over the square root of 2, which is about 0.7. So here's pi over 4, 0.7, and then root 3 over 2 goes with pi over 3, and that's 0.86. Okay, so let's see. It's going to be somewhere up here. And then at pi over 2, we hit a y value of 1. So we have our y's jumping up here until we hit the top of our circle. So this is quadrant 1. Our t increases from 0 to pi over 2, and as it does that, this y height increases from 0 to 1. As we move through quadrant 2, from pi over 2 to pi, our y value is going to decrease from 1 back down to 0. So through here, and there's some symmetry. This should look like it has some symmetry. As t continues through quadrant 3, so from pi to 3 pi over 2, t's go from pi to 3 pi over 2, our y's continue to decrease from 0 all the way down to -1. So if you think about what your y coordinate is doing, it's getting smaller until we hit the bottom. And then last, through quadrant 4, from 3 pi over 2 to 2 pi, our y starts to increase again and ends up back at 0. Okay, so that's one full lap around the circle. So I don't know if this is easier or harder to picture, but basically it's like we split the circle here and we flip it all and roll it out, and the t, the perimeter of the circle, lays along this axis. So these are our t values, how far along the perimeter we've gone. And then our y values we're plotting up above or down below that. As you head the other direction, it's going to do the exact opposite. So if we say this is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, as, excuse me, we head backwards from from 0 to negative pi over 2, our y's decrease to -1. From negative pi over 2 to negative pi, our y's go back up to 0. From negative pi to negative 3 pi over 2, they go back up to 1. And from negative 3 pi over 2 to 2 pi, they go back down to 0. Okay, so there's part of the sine wave. It's going to continue this exact same sort of pattern over and over and over again as you go around and around and around the circle, either direction. So domain and range, we want to talk through some of the characteristics of this graph. So idea would be that you memorize this shape, but I hope that it's not heavy duty memorization. It's more just remembering the picture is a wave, maybe remembering that sine starts at the origin and goes up. The rest of this info, excuse me for so many yawns, the rest of this info comes from your unit circle. So you do still have this as a reference. So sine inputs t values, outputs y values. You can have any t value you want, positive, negative, big or small. T is your arc length, and we can figure out what any arc length means. On top of that, if I can speak here, not only can I deal with any possible arc length in general, no matter what my arc length is, I can always find a y value that goes with it. So the domain is all real numbers. The range will be the set of possible y values. Since we're trapped on the unit circle, those should be between -1 and 1, including -1 and 1. Sine does have some symmetry. We have the rotational symmetry, so if we spin 180 degrees, the graph looks exactly like what we started with, or you can picture taking everything to one side will go to the right of the y-axis and flipping it over the y and then the x-axis, and it should match up with everything that's already sitting on the left-hand side. So sine is an odd function. Symmetry through the origin. You can also see it on the unit circle. So let's see, what this is saying is that if we pick a point and it is a ty pair, then we should also have a point with the opposite t and the opposite y. So that's what we're saying. There should be pairs of points. On the unit circle, you can see it if you say this is your t value and it goes with this y value, going the opposite direction t will give you exactly the opposite y. And then a tiny bit of new vocab here, and then there'll be a little bit more associated with the transformations of trig functions. So sine and cosine, in fact, all of the trig functions are periodic, meaning they repeat the exact same set of outputs over and over and over and over again. So here, what's happening is that we run a full course of outputs if we go all the way around the circle. So every 2 pi, you're going to run the full pattern, and it doesn't matter where you start. So I showed starting at 0 and going once all the way around, but you could start at the bottom and you could go to the top and then back down, and that's one full period. So kind of a nice visual way to think about this, and this kind of emphasizes it right here, is this horizontal shift business. So if we pick up the graph and we shift it either direction by 2 pi, so we pick this up and we shift it by 2 pi, it should look exactly the same. We shouldn't be able to tell the difference. So here, our period p, the amount that we can shift it by and not change the picture, is 2 pi. So period of sine is 2 pi. You have to go all the way around the circle to get the full pattern. Okay, so again, part of this is committing to memory what this graph looks like, but that shouldn't be tons and tons of memorizing points. It should be using the unit circle and having an idea of what you're expecting the graph to end up looking like. The other one that we're going to work on in this section is cosine. So this one's slightly harder, I think, to picture because we need to imagine our x value in relation to our t value. So as we start here at 0, we want to follow as t gets bigger or smaller what our x coordinate does. So if we're starting right here, our x-coordinate is actually 1. We're sitting at the point 1, 0. So when t is 0, x is 1. And we'll do the exact same scale as above so that we can compare. Okay, so x is initially 1. And as t increases, our x is shrinking. You can see I'm down to a fairly small x as t gets close to pi over 2. And when t actually hits pi over 2, my x value is 0. As t goes from pi over 2 to pi, my x-coordinate continues to decrease to -1. So I'm going to have this sort of shape, and it says circular motion. It's going to give me that same approximate shape. Again, feel free to see how this compares with what you'd expect to happen for arc lengths of pi over 6, pi over 4, pi over 3, 2 pi over 3, so on. From pi to 3 pi over 2, my x-coordinate is -1, and then it goes back up to 0. And then from 3 pi over 2 to 2 pi, it continues increasing. My x-coordinate continues increasing to 1. Very similar if we go the opposite direction. So starting with an x-coordinate of 1, as t decreases from 0 to negative pi over 2, our x-coordinate decreases to 0. As t decreases from negative pi over 2 to negative pi, our x decreases to -1. And then we start increasing. So from negative pi to negative 3 pi over 2, our x-coordinate increases back to 0. And then negative 3 pi over 2 to negative 2 pi, it increases to its maximum of 1. Okay, so there is a cosine wave. So very similar to sine. In fact, the only difference between these two, all you have to do is shift one horizontally to make it look identical to the other. So they really do have the exact same wave shape. They're just situated a little bit differently. Okay, so domain is once again all real numbers. Range is once again -1 to 1. But do be clear on the fact that that's x values that we're talking about. Cosine inputs t's. We can input whatever we want. Outputs x's, which are between -1 and 1. I do have symmetry again. This one's symmetric across the y-axis, so that's even, which means if you have a point t, x, oh, I didn't label these, so this is input t, output x. On the graph, so say this is our point right here, we have a t and an x, then you should have a corresponding point over here that has the opposite t but the same x. So that's how even looks. On the circle, we're saying if you go one direction, t units, you get a certain x. If you go the opposite direction, t units, you actually have the exact same x. And once again, the period is 2 pi. You have to go all the way around the circle to get the full pattern for your x values. Okay, so in the future videos, we're going to work on transformations of these two, but your first job is just to work on knowing this picture. So without having a calculator handy, you know exactly what this looks like. Thanks for watching.